Okay, welcome to lecture 3.3. Okay, what I'm going to do is I'm going to start off. Let's talk about the Levitt-Porter paper. And what I think I'm going to do is let's think about the recipe that I gave you for building a likelihood function. Let's do that. We'll go back to some other aspects of the Levitt-Porter paper, but let's first do that recipe. And the first part of the recipe was to form a dependent variable. Okay, so I'm going to call it y sub t. It's observation t, big Y. It's a random variable. What is it? Click pause, try to think of it. Okay, if you're back, it's just the number of drunk drivers involved in a two-car crash. Given a fatal accident, how many of the drivers were drunk? Okay, number of drivers who were drunk in observation T. Remember, each observation is a fatal crash, okay? And in this case, it's always going to be a two-car accident, and they always look at the two drivers, okay? They don't record the number of passengers, the non-driving passengers who might have died. But so just of the two drivers, how many of them were drunk? And so this is just going to equal 0, 1, or 2. Okay, so that's it. Okay, and then your data is going to look something like this. So it's going to be t, and then I could call it a little. Let's call it a little y sub t. That's what we observe, the observed value of the random variable. And it's going to look something like this. Observation 1, let's say there were 2 drunk drivers. Observation 2, there were 1. Observation 3, 1 drunk driver. Observation 4, 0. Observation 5, 2. Okay. All right, so if that's the data, okay, there's more observations than that. I think Steve had something like 100,000 observations. And not only that, what they did, Levitt and Porter, is they split the data up into different times and days of the week. I think they had looked at it, they broke it down so finely, a different hour for each day of the week. So 7 times 24 different breakdowns. So let's think of this as suppose we were looking at just 1 hour and something like Friday night, midnight to 1 a.m. Okay, if this is the data. Okay, if we observe this, then the next thing we do is we're going to have L. And I won't put in all the variables, but maybe we will. We're going to have NS, that's the number of sober drivers on the road at that time, ND, theta D, and theta S. Okay, those are going to be our parameters. And our likelihood function is just going to be something like probability y1 equals 2 times probability y2 equals 1 times probability y3 equals 1 times dot, dot, dot. Okay. So that's what our likelihood function is going to look like. It's going to be something like that. Okay. Now, okay, I'll come back to that board. Next thing, here's what we're going to do. Okay. Okay, so we have each of these cases. Okay, probability. Well, first, we're going to define some terms. Next thing, okay. Levitt and Porter define PDD. That just equals probability for any YT, the number of drunk drivers equals 2. Okay, so next, and then they define, so, okay, DD means it's like both drivers were drunk. they define PDS equals probability. And by the way, we're assuming that all these observations that they're identically and independently distributed. So I say y sub t, that each, observation 1 has the same probability as observation 2 is 3, and so on. Okay. PDS is equals probably y sub t equals 1. Okay. I'm not even sure I did this right, but I think yes. Yeah. There is no PSD. Okay. They define this PDS as a probability that there's only one of the two drivers was drunk, and then PSS is equals probability YT equals 0. Probability the number of drivers that were drunk was 0. So PSS means both the drivers were sober. So even though, okay, when I gave that example, and I'm going to come back to this, I pretended like it was only on one road where one driver is going east and the other driver going west. And so we could say, maybe that first guy is the eastbound driver, the other guy is the westbound driver. So PDS, so PSD would be something different. That's the opposite. Turns out they're exactly symmetrical. Okay. And Levitt and Porter did not do what I did. They did not think of it as a road with one driver going east, one driver going west. They just thought of it as there's two drivers, and then they don't distinguish between the two drivers, whether one is going east or one is going west. And so they look to see whether one of the drivers is drunk. Or if one of the drivers is drunk, that's all the information they use. They don't look to see whether that driver was going east or west. Okay, so I'll come back to that and maybe explain why this matters or why it doesn't really affect the analysis much at all. Okay, so these are the key variables. Okay, we're gonna estimate these things. So. And then, we'll come back. We're going to fill in these terms into our likelihood function. So, for instance, if we did that, now we got to express PSS, PSD, and PSS as functions of NS, ND, theta S, and theta D. Okay, now that's where we're headed. But before we do that, we can look at this likelihood function and just say, well, this just equals PDD, okay? The first observation had two drunk drivers, times PSD, because the second observation only had one drunk driver, times PSD again, because the third observation only had one drunk driver. The fourth had 0, so it's going to be PSS, and then times PDD, and I'm assuming there's more than 5, so let's go ... There's a lot more observations, okay? So that's what our likelihood function is going to look like. All that's left is to write these P terms as functions of the NS, ND, theta D, and theta S. Okay, so that's where I'm going. Let's see, you know what? I've talked for 9 minutes. Why don't I end there? Okay, so that's going to be lecture 3.3. Okay, I'll come back. 3.4, we'll talk a little bit about how exactly to define those P terms. Okay, we'll see you there in lecture 3.4.